So now we're going to look at how do we brominate, in general, halogenate aromatic molecules. So remember, aromaticity is a little bit different than our normal alkenes, right? So even though it looks like we just have 3 double bonds here, remember these are part of an aromatic molecule where these double bonds are swirling around, they're delocalized, and being aromatic is a really good stabilizing effect. Molecules tend to want to be aromatic. So we're going to keep these double bonds. Alright, so the difference from before is we're going to keep our benzene ring, so let's draw that. And we're going to keep the double bonds. Alright, so that's kind of the key to this. And what we do is this is a substitution reaction. So in place of one of the hydrogens, we're going to put a bromine. And what happens is our byproduct is HBr. And so when we initially add the bromine, we break the aromaticity, but it reforms and eliminates the hydrogen. And so this hydrogen is the one that used to be here. Alright, so the key thing with this is that the iron tribromide is your catalyst. Right, so it just makes the reaction go by making the bromine a better electrophile. And then we add only one halogen. Right, so we only add one of them, and we keep all the double bonds in the benzene ring. Alright, let's try another one. So on the bottom one, same idea. We're going to just redraw the benzene ring the way it is. And in this case, we actually have 3 carbon groups coming off. And so if you remember, we just said that it has to replace a hydrogen. So the only places we have hydrogens are in these 3 carbons. And so we're going to replace one of those 3. In this case, they're all equivalent, so it doesn't matter. So we can pick any one of the 3. So we'll just pick the one up here on the top right. And remember, we only had 1 chlorine, so we'll put the 1 chlorine plus HCl. And we don't see any of our iron trichloride in our product as a catalyst, right? The catalyst doesn't show up in our product.